Hi, everyone. Now, when we're doing a question like this where we're working with a system of equations, right? So we're working with a system of equations and it says 3x. So we have, we have this first equation and the second equation, and it's saying, does this order, which ordered pair satisfies it? So basically, we're trying to find which x and y values, when subbed into both of these equations, are a solution. And we're basically trying to find their point of intersection, right? So every time you have a system of equations, you want to identify which method you want to use. So remember, there are two methods. A, where we're doing elimination, and B, where we are doing substitution. So for elimination, if I were to do elimination to a system of equations, let me give you a simple one just to kind of review it real quick. So if I have x plus 1 is equal to, or let's even make it x plus y. Let's make it as simple as possible. X plus y is equal to 1. And then we have x minus y is equal to 2. Okay, so this is our system of equations. First equation, x plus y is equal to 1. Second equation, x plus minus y is equal to 2. So I'm going to call this my first equation, my second equation. If I were to use elimination, now for elimination, we basically want to get rid of one of the variables, right? So if I did this, if I said, let's say I'm going to add these two equations, and I chose it adding them because I see that one over here is positive y, the second is negative y. If I add those two, they go away, right? The y goes away. So that's why elimination could sometimes be really useful because it's a quick way to get rid of a variable and solve for the other one. So let's do that. So I would add, and then I would end up getting 2x plus, and then over here, positive y, negative y, they go away. So that's plus 0y is equal to, and I'm not going to write it because 0y is just 0, right? So is equal to 1 plus 2, well, that's 3. And then if I wanted to solve for x, I can just divide by 2, divide by 2. So x is just going to equal to 3 over 2. But remember, we're trying to find a set of ordered pairs. I'm trying to find x and y. So I just found x, and let's find y. So what I do when I'm doing elimination is once I've found one variable, I want to find the other by using by just subbing it back into any one of these equations. I'm just going to choose 1. Why not? Sub into 1. So if I do that, well, I have 3 over, ooh, that was a 2. So 3 over 2 plus y is equal to 1. And then I want to solve for y, so I just do yikes. I do inverse BEDMAS, so 1 minus 3 over 2. 1 minus 3 over 2. I can get common denominator. This multiplies by 2. I multiplied the 1 on the bottom by 2. So then I have 2 minus 3 all over 2. Y is equal to negative 1 over 2. So that's elimination. Substitution would be a different method where I solve for one of the variables. So let's do it. So this was using A, elimination. B would be substitution. Substitution, I'm going to take one of these equations. I'm going to take the simpler one. Both of them, in our case, this and this one are simple. But if you have one where it's like this, one is a little bit more difficult, just take the simpler one and solve for one of the variables. So I have, for instance, if I take 1, and I do x plus y is equal to 1. I'm going to solve for one of these. I'll just choose y. Why not? Y is equal to 1, and then I bring that over there, minus x, right? Okay, so now I have y is equal to 1 minus x, but that's not what the value of y is, right? We usually want to find a value. So what I do is just I sub that back into the second equation, right? So I say sub into 2, and I can't sub it back into the same one because I got this equation y is equal to 1 minus x from the first equation. So I can't sub it back into it. So I sub it into the second one. So I say, you know what, that's x minus, and then instead of putting y, I'm going to put this stuff because that's equal to y. So x minus 1 minus x, and make sure you put the brackets because if you're going to distribute a negative like this, is all equal to 2. So then I have, okay, that's x minus 1. I need to make sure I'm distributing to both. So x minus 1, x plus, and then plus x is equal to 2. So I get 2x minus 1 is equal to 2. Now, what is that? Now I have 2x is equal to 1, because I brought that negative 1 to the other side. Sorry, 3 becomes a positive 1, right? Plus 1 plus 1. Okay, and then I have x is basically equal to 3 over 2. And it's the same thing we had with substitution, with elimination. Now all I do is, again, I'd sub this value of x back into 1 and find y, which we should be getting the same y over here. So let's look at these two methods and see, okay, well, which one do I want to use in this case? Now, in our case, we see that, look at this. This one is already put in the form of x is equal to something in terms of y. Well, that's beautiful, because you see how over here with substitution, we're trying to make an equation for one of them and then sub it into the other. Well, here they kind of already made it for us in the question, so we're set to go. We can sub this stuff for x right into x up there. And then we're going to have an equation in terms of only y, and we can solve for y, right? Let's do that. So we're going to say sub, and remember, this was other stuff. This was just an example. So now we're doing the actual question. Sub 2 into 1. And I want to just highlight something over here. We said sub 1 into 2 over here. Now, it doesn't matter which I'm subbing into which, as long as, remember, we choose the simpler one, isolate for one of the variables, and then sub it into the other. So I'm going to sub 2 into 1, so I'll have 3. And instead of x, I'll put this stuff, y plus 7, because that's what x was equal to in the second equation. And minus y all over 3 is equal to 21. Now I solve for y, so I'm going to say 3y, right? I'm distributing this 3y plus 21 minus y all over 3 is equal to 21. And then now I just isolate for y. So if I bring this to the other side, that's just 0, right? So I have 3y minus y over 3 is equal to 0, because that's 21 minus 21. And then now I need to get common denominator. So I'm going to say, you know what, over 3, because I'll do 1 times 3, and then 3, I need to multiply by 3 as well, because anything to the bottom goes to the top. So 9y minus y all over 3 is equal to 0. That is 8y all over 3 is equal to 0. Now, I want you to see something here. If I multiply this 3 up here and divide this 8, it doesn't matter, because it's all happening to a 0. So y is technically just equal to 0. You could also look at this as what multiplied by 8 over 3 will give me 0. The only thing that could do that is 0, right? So there you go, y is equal to 0. And because this is multiple choice, I do not need to go further, because if I look at my options over here, the only one where y is equal to 0 is C. So I could confirm. I could just say, you know what, sub y is equal to 0 into, and I'm going to choose the simpler one, right? Because why would I want to try and sub it back into that longer one? So it's into 2, and I'd have x is equal to 0 plus 7. Well, that's just 7, right? So there you go. X is equal to 7, y is equal to 0. But if when you're doing multiple choice, you find your answer right away, it's a process of elimination anyways, right? Keyword there. But yeah, usually you want to confirm anyways. So if it's as simple as this, honestly, just go back and substitute it, right? All right, I'll see you next question. Bye.